Hello, everybody, and today we have day 5 of our review unit. For today's topic of the day, we are going to be working with function notation and also function vocabulary. All right, so if we take a look, our exact goal for today. So number one, there's actually two goals. Number one, given an equation in function notation, you will be able to evaluate to find specific values. And goal number two, given a relation, you will be able to determine the domain, range, and determine if it is a function. Okay, so the second part is all about our function vocabulary. All right, so let's jump right into it and take a look at function notation. Okay, function notation is a special notation used only for functions. Remember, functions are our different types of equations. So linear equations, quadratic equations, and remember, we typically sometimes say f of x is a fancy way of just saying y equals. But in this case, we're going to keep it in function notation because when it's in function notation, it does something very unique. It tells us exactly what value it wants us to find because whatever value is in the parentheses, that's the variable that's going to be in the equation. So if they put a number in the parentheses, that means they want us to substitute all of the x's with that value. So here they want us to make -2 our x value. So what we're going to do now is we're going to rewrite the equation, but wherever we see an x, we're going to replace it with a -2. So this becomes -2 parentheses x. Remember, when you substitute in, you always put it in parentheses. And now we can use the calculator to help us solve. So I'm going to go here to my calculator, parentheses -2 squared plus 5 parentheses -2 minus 6, and we get 12. So that means f of -2 is equal to -12. So this would be my x value, and the whole thing would be equal to my y value. All right, so let's take a look now at example number 2. Now they have f of m. Now they put an m in the parentheses, so that's going to be my x. So what I'm going to do is the same thing we did, but instead of putting in -2 for all the x's, now I'm going to substitute in an m. So if I go back to the original, it's x squared, so I'm going to replace that with an m squared plus 5. Now instead of x, we're going to put an m minus 6. And that's it. That's as far as we can go. All right, let's take a look at two other examples. So let's take a look here. So solve each equation and show your work. So if f of x is equal to 3 times the absolute value of x minus 1, find the function of x plus 2. So now here's what we did. We took x plus 2, we put it in parentheses. So what we want to do now is we want to replace all of the x's in the equation with x plus 2. So I'm going to take that and I'm going to put it in for x. So let's take a look. So now my f of x plus 2 is going to be equal to 3 times the absolute value of, now instead of x, I'm going to substitute in x plus 2 minus 1 absolute value. Now we can definitely simplify here. So f of x plus 2 equals 3 times the absolute value. Now x plus 2 minus 1, I can combine my like terms of a 2 and a -1, so this becomes x plus 1. And with that, we are done. Okay, let's try one more example. So if I take a look over here, if g of x equals 3x plus 5, so if I take a look, here's an x, here's an x. We want to find g of x minus 2. So here's what we're going to do. We're going to take whatever's in the parentheses, and we replace that for the x. So g of x minus 2 is equal to 3. Now instead of x, I'm going to substitute in x minus 2 plus 5. Okay, now let's distribute and let's simplify. So g of x minus 2 equals 3x. So that would be -6 plus 5, which would give us a minus 1. And that would be our final answer. All right, now we can also use function notation when looking at a graph. So if I take a look at question 3, the graph of y equals f of x is shown below. Which point could be used to find f of -1? All right, so f of -1, that -1 is very important there, so we have to think. The number in the parentheses, does that stand for your x or does that stand for your y? Yep, that's going to be your x value. So I want to look, where is my x equal to -1? So let's take a look. Here's your x-axis. We're going to go to -1, which is going to be right here. Now we're going to go all the way up, all the way down. Which point is there? Well, that's point D. So the answer there is going to be point D. Okay, and that's going to be our review on function notation. So now let's take a look at our function terminology, our vocabulary now with functions. So function terminology, domain. Domain are the inputs or the x values. The range is the outputs or the y values. Okay, so those are important. So domain is your x's, range is your y's. Now we can also find your domain and your range on a table of values. Okay, so your domain is the number for the x's, and your range is the number that's in for the y values. Okay, now we can also test for a function to determine if a relation is a function. You need to check to see for every x value there is one and only one y value. In other words, no x values repeat. All right, the second way we can test for a function is to see if it passes the vertical line test. And we're going to look at that when we're graphing. All right, so let's go ahead, let's put this all together. So let's take a look at our first example. The function f has domain 1, 3, 5, 7 and a range of 2, 4, 6. Could f be represented by 1, 2, 3, 4, 5, 6, 7, 2? Justify your answer. Well, let's double check. So if we take a look up here, tests for functions, for every x value, there is one and only one y value. So no x values repeat. Let's take a look. Look at your x's. We have 1, 3, 5, 7. Did any of our x values repeat? Nope. So that means it's good. We also want to make sure that we used all of the points. Let's take a look. 1, 1, we used it. 3, 3, we used it. 5, 5, we used it. 7, 7, we used it. All right, 2, we used it. 4, we used it. 6, we used it. Okay, the y value of 2 does repeat, but that's okay. Y values, it's okay to repeat. So could this be a function? Yes. And I'm going to write because all x values are used and no x values repeat. All right, let's take a look at our next example. Number 5, let f be a function such that f of x equals 3x minus 2. It is defined in the domain from -1 is less than or equal to x, which is less than or equal to 3. Find the range of the function. All right, so they're giving us the domain, the x values. They want us to find the range, which is going to be our y values. Well, remember for what we talked about before over here, your domain is your x's, your range is your y's. We can set it up as a table of values. If they give us the x's, we can find the y's. So let's set this up as a table of values and let's fill it in. So our x's are going to start at -1 and they're going to go all the way to 3. Okay, now I need to find the y values that correspond with the x values. So I'm going to go ahead and I'm going to use my calculator. So remember, f of x is a fancy way of saying y equals, so I'm going to go to my y1 and I'm going to type this in. So we have 3x minus 2. I'm going to go to my table of values and let's take a look. So -1 corresponds with -5, 0, -2, 1, 1, 2, 4, and 3, 7. So that means these are my ranges. So I can go ahead and write range. It is the set of numbers -5, -2, 1, 4, and 7. Okay, next up, number 6. Determine if the following are functions. Explain your answer. So let's take a look at the first example. If I take a look, remember here is your x's, here are your y's. So from start, your input, your output. So if I take a look, Ooh, the number 5 is being used twice. So I'm going to say not function because x value of 5 repeats. Okay, now take a look at the middle one. So let's see. Now we're graphing, so let's see if the vertical line test works. So vertical line, it hits once. Vertical line, oh, it hits twice. So this is going to be not a function because it fails the vertical line test. Now let's take a look at the next one. So let's see, does it pass the vertical line? If I draw vertical lines, does it always hit once? Yes, so this would be yes, function, because it passes the vertical line test. And we've got it. All right, this last question is going to combine everything that we've done today. So let's take a look here, our function notation as well as using our vocabulary. So number 7, swine flu is attacking Koeppel-Keenan. The function below determines how many people have swine flu, where t equals the time in days and s equals the number of people in thousands. Okay, so t equals the time in days. So t, inside the parentheses, this is your time in days. And s equals the number of people in thousands. So whatever the whole thing is equal to is going to be the number of people in thousands. Okay, so let's take a look now at part A. Find s of 4. Now 4 is in the parentheses, so that means I want that to be equal to my t. So I'm going to go ahead and this is going to be 9. Now instead of t, we're going to replace it with a 4 minus 4. So we can go ahead, 9 times 4 minus 4, and we get 32. So what does s of 4 mean? It means, well, the 4 is in the parentheses, so that's the day. So on day 4, and then what's the whole thing equal to? 32, and that's the number of people in thousands. On day 4, the number of people with flu is 32,000. Okay, so now part C. Find t when s of t equals 23. Now the 23 is not in the parentheses, it's equal to it. So now we're going to take 32 and we're going to set it equal to 9t minus 4. We want to find t, so let's solve for t. So I'm going to add 4. So I'm going to get 27 is equal to 9t, divide both sides by 9, and t is equal to 3. So what does s of t equal 23 mean? Well, we got t to be equal to 3. Remember, t is the time in days. So that means on day 3, the number of people with the flu is 23. Remember, this is the number of people in thousands. And we've got it. All right, and last but not least, because this is a function, we can always graph it. So graph the function. Remember, s of t is just a fancy way of saying y equals 9x minus 4. So we're going to start at negative 4. 1, 2, 3, 4. We're going to go up 9 and over 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. Over 1. All right, we can't fit any more on, so we're going to go ahead now and just draw our line. So I don't have a ruler with me. I'm just going to take the side of my paper here, and I'm going to draw my straight line. So this would be s of t equals 9t minus 4. So we can see it's growing very fast. All right, that's everything for function notation. and function vocabulary.